Let's talk about place value. Now, if you're like me, you learned place value when you were a kid, and you memorized the pattern of behavior that it follows, and you're able to use it to do computations without even thinking about it. But also, if you're like me, the first time you learned place value, you didn't fully understand what was actually happening and why it was so special. There is usefulness in doing this, not just for the sake of understanding place value, but because there are many other ideas related to place value, such as how number systems work in general, that become more clear when we fully understand place value, what the motivation behind it is, and what the underlying principles are. So I'm going to talk to you about place value and number systems, but I'm going to do it by using a story to try to motivate some of the ideas in place value. And so I'm going to tell you a story about an individual called Matthew. It's a complete lie. I've totally made it up, but the ideas that it will convey are useful. And for me, it's useful to have such ideas in context. So we're going to tell a story about an individual named Matthew. And Matthew goes by Math for short. See that? I made a funny. That's funny, isn't it? Moving on. Matthew lives on an island where they've not yet invented numbers. Okay? Now, as far as occupations go, Matthew is a sheep herder, and he's a pretty good one. However, Matthew is not a very happy sheep herder. Why, you ask? Well, because due to the fact that on his island they don't have numbers, if Matthew wishes to participate in commerce, to trade his sheep for other sheep, or for chickens, or for pigs, or whatever it is that he's trying to trade for, he has to bring his sheep with him. That poses a problem because, well, sheep are loud and not super intelligent, and they come with a certain aroma. All right? So Matthew would very much like to be able to be a sheep herder that doesn't always have to have his sheep with him, to be able to talk to people that he'd like to trade with and so forth without the noise and the smell and the strange decisions being made by his animals all around him. So he begins to have this idea, well, what if I intentionally put marks in my cane to represent my sheep? One mark for each sheep. So he does this, and he begins to prosper. Everybody does, because it's so much easier to be productive. So he thrives and finds himself unhappy again. You see, as the number of sheep that Matthew has increases, so does the amount of space he needs in order to keep track of these tick marks, we'll call them, that represent his sheep. Now, it's true, a tick mark is smaller than a sheep, but the relationship between these tick marks and the sheep that they represent is problematic. Let's take a closer look. So as it is, Matthew is using what we would refer to as a base 1 number system. It has one symbol, these tick marks, and each tick mark represents a sheep. Number of marks equals number of sheep. So a single sheep, single mark, and so forth. And what we end up with is what's known as a linear relationship. And so at the same rate that the sheep are increasing in number, the number of marks we have to use to represent them is also increasing. So even though they take less space, as the number of sheep gets very large, this becomes problematic. So Matthew puts on his thinking cap again, and he has another idea. We'll call this his base infinity idea. And what he's aiming for is the ability to use one symbol to represent any number of sheep. So the basic scheme here then would be that as the number of sheep increases, the number of symbols that is needed does not. There's a constant relationship. One symbol for any number of sheep. The drawback, of course, is that he's got to now assign symbols to these different values. So he begins by saying, I'm going to use this symbol here, the one we refer to as 1, to represent a single sheep, much like a tick mark did before. And then he comes up with the 2, the 3, the 4, and so forth. Eventually he decides, you know what, I can't think of any more symbols like this, I'm going to use the symbols that we use in our writing. And so he does that. He uses the letters of their alphabet. When he runs out of those, he begins making up symbols that, to us, make it look like he's getting a little bit upset. And he probably is, because he's realizing that this won't work. It's simply not feasible to invent a new symbol for every possible value that we're wanting to represent. So base infinity won't work. So Matthew sits and ponders some more. Is there a way that we could kind of combine these ideas? That we could get the space savings of the base infinity model with the practicality of the base 1 model, where we only had one symbol that we had to identify and remember. As he's thinking about this, he begins to ponder on his sheep and the way that he's been keeping his own records because of the massive number of sheep that he has. Okay, so this diagram is representing a pen with sheep in it. And so initially, as Matthew began to acquire sheep, he kept them all in the same pen, up until he had 10 sheep in the pen, at which point he had a decision to make. Do I continue to grow the pen and put all of the sheep inside of it, or do I build new pens, each of which can hold some small number of sheep? He opts for the latter. In fact, he decides, I'll build more pens and I'll make them the same size so I can put 10 sheep in each of them. So that's what he does. He finds himself then in his own records not merely keeping track of the number of sheep that he has, but simplifying things a little bit by trying to count pens. And so he starts associating a tick mark with a pen that's filled up instead of just with individual sheep. Now, as he continues to prosper and the number of sheep that he has increases, eventually he feels a need to think about 10 of these pens as one unit, the same way that he thought of a pen which contained 10 sheep as one unit. And so he decides to assign the name flock to 10 of these pens that are filled. Now, as his sheep continue to multiply and he continues to be productive, the number of flocks that he has continues to increase as well. And so he has in his mind this notion that eventually he's going to have 10 of these flocks, at which point he's actually planning on inventing a new term, he hasn't thought of it yet, for these 10 flocks. So just as a recap, when he's thinking of sheep that don't fill up a pen, less than 10 of them, he just numbers them as sheep. When he's thinking of pens that are all full, that don't add up to 10, i.e. a flock, then he numbers them as pens. Otherwise, he counts 10 full pens as a flock. And if you think about it for a minute, no matter how many sheep that you gave to Matthew, he'd be able to use this kind of a scheme in order to keep track of them. Sheep, then pens, then flocks, and then other terms that embody larger and larger groups. Now also notice that even if he chose not to use 10 as the base of this algorithm, suppose he put 3 sheep in a pen and 3 pens in a flock and so forth, it would still work. You could take any number of sheep you wanted and you could stick them in those pens and so forth, and as long as you kept building pens and inventing new terms, it would work. Okay, so what Matthew has stumbled across is something we refer to as, if I can get there, looks like I'm jumping ahead of myself. We'll put it up in a moment. This is something we refer to as place value, and we can see it at work inside of Matthew's records. So if we were to look at a scroll he's keeping, for instance, then we might see these 3 columns. The first one where he's numbering sheep that don't add up to enough to count as a pen. The second one he's labeled pens, which are the number of pens that are filled, but that together don't add up to 10 pens, which would count as a flock. And then finally, the number of flocks that he has, which are groupings of 10 pens that have each been filled up. Okay, there it is. So again, what Matthew's working with here is something that we call place value. Got ahead of myself. Okay, now, when thinking about the infinity model, Matthew came up with some useful symbols to represent different values. And he recognizes the usefulness in using them here. These tick marks are still taking a lot of space, and visually this is not very appealing. You could imagine easily, especially if you're being kind of cramped in the way that you're recording this, ending up with these tick marks so close together they're hard to tell apart. And so he actually begins to use some of these symbols, 1 through 9 specifically, that he invented for the infinity, or the base infinity model, to represent his sheep. And so we'll go ahead and change that. So this is what his records might look like. He has 4 flocks, 2 pens, and 6 sheep. Now, we already know that that is going to be 426 sheep, because we're used to place value. And perhaps we recognize the correspondence between powers of 10 and each of these columns. The first column could be thought of as the number of these units, which are sheep, multiplied by 10 to the 0. Any number raised to the 0th power is 1. So we have 6 times 1 sheep. The second column then is pens, and so we have 2 of these, and each pen represents 10 to the 1st power sheep. So this will be 10 sheep times 2 is 20. And then finally, flocks. In this column, we're dealing with 10 raised to the 2nd power, or 100 sheep per flock. So we have 4 times 100. That's 400 sheep. Adding these together, we have the total of Matthew's sheep. And again, this is something we're used to doing. So it's not new to us. However, it's new to Matthew. And as he's thinking about this, he's realizing there's a lot of potential in this simple scheme he's been using to simplify his life. However, he recognizes there's a weakness, and that is that if you erase the annotations he's made, if you don't have labels saying sheep and pens and flocks and so forth, then there's a very real danger of things. Specifically, let's consider a situation in which there are a number of pens that are filled that don't total 10, so they can't be counted as a flock. So we would record them here as 2. But that there aren't any spare sheep in a pen that's not filled up. Okay, so for instance, a pen with 6. There aren't any of those. And so we don't have a value for this particular column. Without our labels, though, that's not made clear that there simply aren't any individual sheep that don't fill up an entire pen. And so without that there, one might look at Matthew's records. Indeed, he might look at them at some point and say, well, that's 2 sheep, isn't it? So he looks at this and realizes he needs to have a way of representing none, that there are no somethings. And so what he stumbled across is the concept of 0. So he decides to name the idea and the symbol just that, 0. So this symbol explicitly means I have none of these. And so now we see that this value, or this set of symbols, is very explicit in its meaning. There are no sheep that don't fill a pen. There are 2 pens that are filled with sheep, but there are only 2 of them, so they don't fill a flock. And then there are 4 flocks that are filled to capacity with 10 pens, and you get the idea. Okay, so moving on. We've added 0 then to the set of symbols that Matthew is using in his new number system. Let's look at the implications then of this scheme or algorithm that he is applying. Notice that for 0 through 9 sheep, a single symbol is enough to represent the value. Moving on from there, from 10 sheep up to 99, 2 symbols is enough. And we'll end here. This could go on, but you'll notice then that 3 symbols is enough to represent 100 to 999 sheep. So each time that we add a symbol, we multiply the number of values that we can represent by 10. So with 1 symbol, we can represent 0 through 9, 10 things. 2 symbols, 0 through 99. That's 100 different values. And so forth, there being 1,000 possible, 0 through 999, if we have 3 symbols. And this goes on and on and on. Now, we refer to this relationship as being logarithmic. Okay, and that's because we're now dealing with an exponent. Each time that we add a digit or a symbol that can to our representation of a value, we multiply the total number of values available by 10. And so that's acting like 10 being raised to a power. So let's recap the 3 ideas that Matthew looked at. His first idea was base 1. And we saw that it had a linear relationship in terms of the number of things we're counting, in Matthew's case it was sheep, to the number of symbols that are needed. Then he thought of base infinity, and we saw that it had a constant relationship. There was always 1 symbol that could represent any value. But we saw it's not practical because we can't think of that many symbols or remember them even if we could. Finally, we looked at what I'm going to refer to as a base-end scheme. This was Matthew's place value approach. And he used the base of 10. But the idea I'm trying to convey here is 10 wasn't what made his approach so powerful. It was the place value part, the idea that the position of the numbers carried meaning. That was the significant part. Sometimes as children, we get the notion, indirectly perhaps, that it's the fact that we're using 10 that's so powerful when we use place value. But in reality, it's the scheme itself. Whether we were using 3 for the base or 5, it would still work. The results would be slightly different, but in general, the curve that's generated when we look at a mapping between the number of symbols we have to use and the number of things that we can represent, that curve would remain logarithmic. The shape would change slightly, but it would still be something that tapered off over time. Okay, this makes Matthew very happy. He now kind of has the best of both worlds, and that's what place value does, is it gives us the ability to use a small set of symbols while being able to still represent very large values without needing to use very many of those symbols. So life is good. That's where I'm going to leave this. Matthew and I wish you a good day. Until next time.